Welcome to Lesson 3.1. We've covered the history of AI, and we've demystified the terminology. Now it's time to look at the present. Who is actually building this technology? Who has the most users, the most revenue, the most momentum? This lesson introduces the 4 companies that define the current AI frontier, and why each one is betting on a completely different strategy to win. At the top of the AI market right now, 4 companies stand apart from everyone else: OpenAI, Google, Anthropic, and xAI. What makes this interesting is that they aren't all competing on the same terms. OpenAI is chasing consumer scale, as many users as possible. Google is betting on ecosystem lock-in, making Gemini unavoidable if you use any Google product. Anthropic is focused on enterprise precision, winning the highest value business contracts. And xAI is running a speed-first game, building more compute faster than anyone thought possible. 4 companies, 4 completely different theories of how to win. OpenAI is the company that started the current wave. ChatGPT launched in November 2022 and became the fastest consumer product to 100 million users in history. As of early 2026, ChatGPT has 900 million weekly active users. That's more than 10% of every human being on Earth using it every single week. Revenue has tripled year over year. Their GPT 5.4 model scores 74.9% on SWE Bench, real software engineering tasks. And they're preparing for a potential IPO at between $550 and $600 billion. The risk? They're losing enterprise ground to Anthropic, even as their consumer base continues to grow. Google's AI division, formed by merging DeepMind and Google Brain, is the distribution giant. Gemini went from roughly 5% to over 21% market share in just 12 months. That's the fastest rise of any major AI platform in history. The secret? Google doesn't need you to visit Gemini.ai. Gemini is built into Android, Chrome, Search, Gmail, and Google Docs, products used by over 3 billion people. Gemini 3.1 Pro also leads the GPQA benchmark at 94.3%, graduate-level science questions. And let's not forget DeepMind's AlphaFold, which solved protein folding, a 50-year-old biology problem with enormous implications for medicine. Anthropic has the most counterintuitive story in AI. Claude holds only 2 to 4% of consumer web traffic, but in the enterprise market, Anthropic wins approximately 70% of new contracts against OpenAI head-to-head. 8 of the Fortune 10 companies are now Claude customers. Annualized revenue hit $14 billion in February 2026, growing 10 times annually for 3 consecutive years. That velocity makes Anthropic one of the fastest-growing technology companies in history. Claude Code, their AI coding tool, generates over $2.5 billion annually on its own. The lesson: market share and business impact can point in completely different directions. xAI is Elon Musk's AI company, founded in 2023. Its strategy is unlike any other: build the fastest, at whatever cost. The result is Colossus, currently the world's largest AI supercomputer, built in a former factory in Memphis, Tennessee, in just 122 days. The industry average for a project like this is 4 years. xAI then doubled it to 200,000 GPUs in 92 more days. The target is 1 million GPUs and nearly 2 gigawatts of total computing capacity. Their Grok 4 model leads the SWE bench coding benchmark at 75%. xAI was recently valued at $230 billion and has now become a subsidiary of SpaceX. The Big Four aren't alone. Next lesson, we look at the challengers: Meta, DeepSeek, Mistral, and the open-source wave that's threatening to rewrite the economics of AI entirely. See you in Lesson 3.2. Welcome to Lesson 3.2. The Big Four make the headlines. but the challengers may end up changing the game more fundamentally. This lesson is about the companies and approaches that don't fit the closed model playbook and why they matter. In AI, open source has a specific meaning. The model weights, the billions of learned values that make an AI work, are publicly released. Anyone can download, run, modify, and build on them for free. This is a direct threat to the business model of companies like OpenAI and Anthropic. If a free open model performs at 90% of a closed model's quality, most businesses will choose it. The cost drops to near zero. The competitive advantage shifts away from the model itself and toward what's built around it: the product, the service, the integration. For the world, open source AI means that researchers, startups, and developing nations can build on frontier AI without paying API fees or depending on a US tech company's terms of service. Meta's strategy is simple and radical. Release everything. The Llama model family, now in its 4th generation, is publicly available, with versions ranging from models small enough to run on a laptop to 405 billion parameter giants. The quality is competitive with closed models. The price is zero. Why does Meta do this? They spend around $40 billion a year on AI infrastructure. Open sourcing the model costs almost nothing extra, but it accomplishes two things. It commoditizes the model layer, forcing rivals to compete on price, and it builds goodwill with the developer community that builds on Meta's broader ecosystem. Meta doesn't need to win with Llama directly. It wins by making everyone else's model less valuable. In January 2025, a Chinese AI lab called DeepSeek released a model that matched GPT-4 in quality, at a reported training cost of around $6 million. For context, comparable US models cost over $100 million to train. The AI world stopped. DeepSeek holds 89% market share in China and a surprising 3.7% globally, despite being released just over a year ago. When the news broke, NVIDIA's stock dropped 17% in a single day because DeepSeek proved you don't need the most expensive compute to get frontier results. If efficient architecture can compete with raw compute, the $500 billion Stargate bet looks very different. Open source, from China, may be the biggest structural challenge to the closed model business model. Mistral is a French AI company founded in 2023 by former Google DeepMind and Meta researchers. It's Europe's most funded AI startup, and proof that great AI doesn't require Silicon Valley. Their Mistral 7B model, released as open weights, outperformed models 5 times its size. Their Mixtral architecture used a technique called mixture of experts to punch far above its weight class. Their consumer product, Le Chat, positions as the privacy-conscious European alternative to ChatGPT, with GDPR compliance built in by design, not as an afterthought. For countries that don't want to depend on US or Chinese AI infrastructure, Mistral is a genuine alternative. Small team, outsized output, and a regulatory environment in Europe that may actually work in their favor. The open versus closed debate in AI isn't just technical. It's about who controls the technology and under what terms. Open source wins on cost, privacy, and customization. Closed source wins on quality at the frontier, support, and the ability to enforce safety controls. The best open models now reach roughly 90% of closed model quality on most benchmarks. That remaining 10% matters for some applications and not at all for others. The honest answer is that neither approach wins universally. Most sophisticated organizations end up running a mix: open source for cost-sensitive or privacy-critical workloads, closed models for frontier tasks where quality is non-negotiable. Enough strategy talk. Next lesson, we get completely concrete. What do the actual user numbers say? What does the revenue data show? Who is winning the AI market in April 2026, and by what measure? See you in Lesson 3.3. Welcome to Lesson 3.3. This is the data lesson. We're going to look at user numbers, revenue figures, and market share data, the actual scoreboard of the AI race as of April 2026. No hype, no spin, just the numbers and what they actually mean. Let's start with the number that's hardest to fully comprehend. ChatGPT has 900 million weekly active users. That's more than 10% of every human being on Earth using the product every single week. The platform processes approximately 2.5 billion prompts per day. For context on how it got here, ChatGPT reached 1 million users in 5 days, 100 million in 2 months. No consumer product in history grew faster. And between early 2025 and early 2026, its weekly user base grew by 500 million people, meaning it added roughly the population of the United States twice in a single year. This chart shows AI chatbot market share as of April 2026. ChatGPT leads at 66%, down from 87% a year ago. Gemini is in second place at 21%, up from just 5%. The fastest rise in the category's history. Then come Copilot at around 7%, DeepSeek at 3.7%, and Perplexity, Claude, and Grok each at roughly 2%. Two things stand out in this data. First, the ChatGPT monopoly is over. The market has genuinely fragmented. Second, Claude's 2% web traffic share coexists with winning 70% of new enterprise contracts. Traffic share and business impact are telling completely different stories. Now the revenue picture. OpenAI leads with around $20 billion in annualized revenue, targeting $29 billion by the end of 2026. Anthropic is at $14 billion as of February 2026, up from $1 billion just 13 months earlier. That trajectory is steeper than OpenAI's. At current velocity, industry analysts project Anthropic could surpass OpenAI's revenue run rate by end of 2026. Google Gemini's standalone revenue is harder to isolate. Google integrates Gemini across its entire business. xAI is earlier stage, with revenue growing rapidly alongside Grok adoption. The headline: this is a two-horse revenue race right now between OpenAI and Anthropic is closing fast. The most important insight in the 2026 AI market is that the consumer market and the enterprise market are moving in opposite directions, with different winners. In the consumer market, distribution wins. ChatGPT wins on raw scale. Gemini wins by being unavoidable in Google products. In the enterprise market, precision wins. Claude wins because businesses care about accuracy, safety, and compliance, not just how many users the product has. 1 in 4 businesses on the RAMP platform now pays for Anthropic. A year ago, it was 1 in 25. 8 of the Fortune 10 are Claude customers. The right question isn't which AI is winning. It's winning what and for whom. Here's the last thing the data shows. Nobody picks just one AI anymore. About 1 in 5 weekly AI users now uses multiple platforms regularly. The platforms have already differentiated into distinct use cases. ChatGPT for general questions and brainstorming. Claude for deep work, coding, and enterprise workflows. Gemini for Google Workspace tasks. Perplexity for research that needs cited sources. DeepSeek for cost-sensitive use cases. Grok for real-time social data. The market has moved past single-platform thinking. The most sophisticated users are routing different tasks to different tools and getting better results because of it. Next lesson, we get even more specific. How do you compare AI models objectively? What are the standardized tests that measure capability? And more importantly, what do those tests miss? Lesson 3.4 is the benchmark lesson. See you there. Welcome to Lesson 3.4. User numbers tell you who's popular. Revenue tells you who's making money. Benchmarks tell you who's actually capable. This lesson explains how AI models are tested, what the most important benchmarks measure, how the top models currently score, and, critically, what benchmarks don't tell you. A benchmark is a standardized test, a fixed set of questions or tasks that any AI model can be run against to produce a comparable score. Think of it like a standardized exam. Just as the SAT gives colleges a common way to compare students from different schools, benchmarks give researchers a common way to compare models trained in completely different ways. The questions are fixed, the conditions are consistent, and the scores are comparable. The challenge is that benchmarks can be gamed. If a model's training data included the benchmark questions, something called data contamination, the score is inflated and means less than it appears. This is a real problem in the field, and it's why no single benchmark score should be taken at face value. 3 benchmarks come up most often in serious AI evaluation. SWE Bench presents real GitHub issues, actual bugs from real software repositories, and asks the model to fix them. This is not a toy problem. It tests real software engineering capability. GPQA presents graduate-level science questions in biology, chemistry, and physics. Questions so hard that PhD students who aren't specialists in that exact area score only around 34%. It tests genuine scientific reasoning, not memorization. MMLU covers 57 subjects: law, medicine, history, math, computer science, and more. It's the most widely cited benchmark, but all frontier models now score above 85%, making it increasingly too easy to distinguish between the best models. Here are the current scores for the 2 most discriminating benchmarks. On SWE Bench, the coding benchmark, Grok 4 leads at 75%, followed by GPT 5.4 at 74.9, Claude Opus 4.6 at 74, and Gemini 3.1 Pro at 63.8. On GPQA, the science reasoning benchmark, Gemini 3.1 Pro leads at 94.3%, followed by GPT 5.4 at 92.8, Claude Opus 4.6 at 91.3, and Grok 4 at 88. The honest takeaway: at the frontier level, all 4 models are remarkably close. No single model dominates every benchmark. Grok leads coding, Gemini leads science, Claude leads writing quality, GPT leads general versatility. The gap between any of them is smaller than the gap between all of them and where models were 2 years ago. Knowing the benchmark scores is useful. Knowing what they don't capture is equally important. Benchmarks don't measure consistency. A model that averages 90% but fails catastrophically on 10% of queries may be worse for your use case than one that scores 85% reliably. They don't measure real-world complexity. Benchmark questions are well-defined, but real tasks are ambiguous, multi-step, and context-dependent. They don't measure conversational quality, how pleasant and helpful a model actually is to work with. They don't measure safety behavior, how a model handles edge cases and adversarial prompts. And they don't account for cost or speed. A model that scores 95% but costs 10 times more may simply not be the right choice. Here's the practical conclusion. The most important benchmark you can run is your own. Take the 3 tasks you use AI for most. Run the same prompt on 2 or 3 models. Compare the results honestly. Evaluate on the criteria that actually matter to your work: accuracy, tone, speed, cost, or format. That score matters more than any published leaderboard. Published benchmarks help researchers track progress at the frontier. They're a useful starting point, but your use case is not an average. Test for yours. One more lesson in Chapter 3. We've covered who's building, what the numbers say, and how to compare models. Now we get completely concrete. Who is actually using AI For what? And where is it genuinely working versus where does it still fall short? That's lesson 3.5. See you there. Welcome to lesson 3.5, the final lesson of chapter 3. We're going to put all the strategy and statistics aside for a moment and get completely specific. Where is AI actually being used? What's working? What isn't? Industry by industry, here's the honest picture of AI adoption in April 2026. Software development is the domain where AI adoption is most mature. The majority of professional developers now use AI coding tools in their daily workflow. The four biggest players are Claude Code, which generates over $2.5 billion in annualized revenue and is the dominant agentic coding tool. GitHub Copilot, Microsoft's AI pair programmer, with 1.8 million paid subscribers. Cursor, an AI-native code editor built on Claude models, the fastest-growing developer tool of 2025. And platforms like Replit and Lovable, which enable non-developers to build functioning applications using AI. This is the furthest along vertical. The results are measurable. The adoption is real and accelerating. Healthcare and science are where the stakes are highest, and where some of the most remarkable results are emerging. AI-powered medical imaging systems can now detect diabetic retinopathy, flag early-stage cancers in mammograms, and identify tumors in MRI scans, matching or exceeding specialist accuracy in controlled studies. DeepMind's AlphaFold solved protein folding, a 50-year-old biology problem, and has already impacted over 1 million researchers. AI clinical documentation tools, ambient scribes that listen to patient-doctor conversations and automatically write clinical notes, are saving doctors 1 to 2 hours of administrative work per day. And the Genesis mission, which we'll cover in Chapter 4, is unlocking decades of U.S. National Laboratory scientific data for AI-accelerated research. In knowledge work industries, AI is no longer a pilot, it's becoming infrastructure. Legal teams use AI for contract review, finding and flagging risk clauses in documents that would take humans days to read. Financial analysts use it for earnings call analysis, fraud detection at scale, and automated report generation. JP Morgan is using Claude through Project Glasswing for defensive cybersecurity across critical financial infrastructure. In business operations broadly, AI handles first-line customer support at 40 to 60% automation rates, drafts sales outreach, screens resumes, and generates marketing content. The key qualifier in all of these, human review remains essential. AI accelerates the work. Humans still own the judgment. Education and creative industries are both experiencing AI as simultaneously a tremendous opportunity and a serious challenge. In education, AI tutors can adapt to individual learning styles and reach students who don't have access to private tutoring. But AI also makes academic dishonesty trivially easy, and universities are still figuring out what learning is supposed to look like in this environment. In creative industries, the disruption is accelerating faster than most people expected. Midjourney and Adobe Firefly are in daily use at design studios. Suno and Udio generate full songs from text prompts. Google's VO3 produces cinematic video that was widely seen as the breakthrough moment for AI video in 2025. The tools are real. The economic disruption to creative work is real. The question of how creative professionals adapt is still very much open. Here is the honest picture. AI is genuinely working today for coding assistance and code review, document summarization at scale, first draft generation with human editing, data extraction from unstructured text, Tier 1 customer support automation, and FDA-approved medical imaging analysis. AI is still unreliable for autonomous multi-step tasks without human oversight, high-stakes factual accuracy without verification, consistent long-form creative quality, real-time decision-making in physical systems, nuanced legal or medical advice without review, and emotional support as a substitute for human connection. The gap between what AI can do in controlled demos and what it can be trusted to do reliably in production is real and narrowing, but not gone. Chapter 3 is complete. You now know who the key players are and how they differ strategically. You know who the challengers are and why open source matters. You know what the real user numbers and revenue figures say. You know how to read benchmark scores and what they miss. And you know where AI is actually working today, industry by industry. Chapter 4 is next. We're going to zoom out to the biggest bets being made right now on the future of AI. Stargate, Colossus, the Genesis mission, and the question of what comes after all of this. See you in Chapter 4.